Have a wonderful day. Welcome to eLearningHub, signing on to give you another insight. Now we're going to talk about Shannon-Weaver's model of communication. Communication is very important. It is the key to understanding between people. Through the years, communication has evolved. The way people communicate with each other today is entirely different from the prehistoric era. Before, communication is limited to person interaction until it evolved to cave painting, smoke signals, pigeons carrying the message, etc. until the discovery of telephone. Now, the internet era has paved the way to innumerable means of communication. Technology has indeed redefined communication. People no longer have to wait for years, months, weeks, and days to receive an information or message. Nowadays, texts, emails, tweets, and personal messages can reach the recipient in just a matter of seconds. The Shannon-Weaver's model of communication is a mathematical theory of communication which argues that human communication can be broken down into six key concepts: sender or information source, encoder or transmitter, channel, noise, decoder or reception, receiver or destination. A later version of the theory by Norbert Wiener added a feedback, the seventh concept, which changed the model from a linear to cyclical model. Shannon-Weaver's model of communication was created in 1948 when Claude Elwood Shannon wrote an article, A Mathematical Theory of Communication, in Bell System Technical Journal with Warren Weaver. The mathematical theory later came to be known as Shannon-Weaver's model of communication. It is known as the mother of all models because of its wide popularity. The model is also known as information theory or the Shannon theory because Claude Shannon was the main person who developed the theory. Many believe this mathematical theory of communication was mainly developed by Claude Shannon alone, and Warren Weaver had a minimal role. It is often simply called the Shannon information theory in science disciplines. Shannon developed the theory to improve understanding of communication via telephone and eventually improve the quality of phones. It was later used as a general theory of communications. The model's primary value is in explaining how messages are lost and distorted in the process of communication. Let us know the developers of the model. Claude Elwood Shannon was an American mathematician and electrical engineer who laid the theoretical foundations for digital circuits and information theory, a mathematical communication model. Warren Weaver was an American scientist, mathematician, and science administrator. He is widely recognized as one of the pioneers of machine translation and as an important figure in creating support for science in the United States. The Shannon-Weaver's model of communication follows the concept of communication in a linear fashion, from sender to receiver, with the following steps. The model starts with the sender or information source, which refers to the person who has the information to begin with. The information source starts from the process by choosing a message to send, someone to send the message to, and a channel through which to send the message. An example of a sender might be the person calling someone. He or she will choose what to say and how to say it before the conversation begins. The second step is the encoder or transmitter. The encoder is the machine that converts the idea into signals that can be sent from the sender to the receiver. This model was designed originally to explain communication through means such as telephone and computers, which encode our words using codes like binary digits or radio waves. Example: the encoder might be a telephone, which converts our voice into binary ones and zeros to be sent down the telephone lines, the channel. Another encoder might be a radio station, which converts voice into waves to be sent via radio to someone. The next concept is the channel. The channel of communication is the infrastructure that gets information from the sender and transmitter through the decoder and receiver. We also call this as the medium. Example: a person sending an email is using the World Wide Web, Internet, as a medium. A person talking on a landline phone is using cables and electrical wires as their channel. The fourth concept is noise. Noise interrupts the message while it's on the way from the sender to the receiver. It is named after the idea that noise could interrupt our understanding of a message. There are two types of noise: internal and external. Internal noise happens when a sender makes a mistake in encoding a message or a receiver makes a mistake in decoding the message. Here are 2 points where it can happen. At the point of encoding, when you misspell a word in a text message. At the point of decoding, when someone misinterprets a sentence when reading an email. Example of internal noise may include someone having a headache so he can't concentrate, someone speaking with a heavy accent, or when the sender mumbles when speaking. Second, external noise. External noise happens when something impedes the message, like at the point of transmission through the channel. For example, when we're having a conversation by a busy highway and the receiver is having trouble hearing over the sound of cars. One of the key goals for people who use this theory is to identify the causes of noise and try to minimize them to improve the quality of the message. Examples of external noise may include the crackling of a poorly turned radio, a lost letter in the post, an interruption in a television broadcast, or a failed internet connection. The fifth concept is decoder. Decoding is the exact opposite of encoding. Shannon and Weaver made this model in reference to communication that happens through devices like telephones. So, in this model, there usually needs to be a device that decodes a message from binary digits or waves back into a format that can be understood by the receiver. Examples: decoders can include computers that turn binary packets of ones and zeros into pixels on a screen that make words. A telephone that turns signals such as digits or waves back into sounds. And cell phones that also turn bits of data into readable and listenable messages. The next step is receiver or destination. This is the step where the person finally gets the message or what is left of it after accounting for noise. Examples of a receiver might be the person on the other end of a telephone, the person reading an email you sent them, an automated payment system online that has received credit cards details for payment, etc. The final step is feedback. Actually, the feedback step was not originally proposed by Shannon and Weaver in 1948. Norbert Wiener came up with the feedback step in response to criticism of the linear communication. Feedback occurs when the receiver of the message responds to the sender in order to close the communication loop. The receiver might respond to let the sender know if he or she got the message or to show the sender whether the receiver got the message clearly without noise. How well receiver understood the message. Nonetheless, the feedback elements seem like a post hoc add-on to the model and is the subject of a lot of criticism. Sometimes when feedback will occur include during a chat between friends, when you are writing a reply on an email, etc. Example, a telephone conversation. The sender is the person who has made the call and wants to tell the person at the other end of the phone call something important. The telephone turns the person's voice into a series of binary data packages that can be sent down the telephone lines. The channel is the telephone wires itself. Noise may occur if the speaker mumbles, the telephone wires are interrupted in a storm, or the telephone encoders or decoders are malfunctioning. The telephone that the receiver is holding will turn the binary data packages it receives back into sounds that replicate the voice of the sender. The receiver will hear the sounds made by the decoder and interpret the message. The receiver may speak in response to let the sender know what the receiver heard or understood. Based on the feedback given by the receiver, we could know now that there is a noise encountered during their conversation because the receiver asked to repeat the message. The Shannon-Weaver's model of communication has many pros and cons. Advantages. It explains the barriers of effective communication very well. The Shannon-Weaver information theory was revolutionary because it explains the concept of noise in detail. It shows how information is interrupted and helps people identify areas for improvement in communication. For example, the model also includes three levels where communication can be interrupted. These are the technical problems, semantic problems, and effectiveness problems. Technical problems, when the decoder, encoder, or channel causes the problems. For example, when a machine important for the communication for the message has an error. Semantic problems. This is when the message that was sent is different from the message that was received. Effectiveness problems. This explains how well the message can cause a response or reaction from the receiver. The second advantage, it breaks down communication into understandable parts. The model enables us to look at the critical steps in the communication of information from the beginning to end. Third, transferable to multiple situations. The communication model was originally made for explaining the communication through technological devices. However, it has been used to explain just about any form of communication you can think of. Here are the disadvantages. First, It is a linear model. There is insufficient regard for feedback. The original 1948 Shannon-Weaver blueprint did not contain the feedback component. When it was added by Weaver later on, it was included as a bit of an afterthought. Thus, it lacks the complexity of truly cyclical models such as the Osgood-Schramm's model. Second, it doesn't account for power relationships. And the model doesn't take a social scientific look at how information is interpreted differently based on power relationships or identities of those people communicating with one another. Third, it doesn't address one-to-many communication. The mother of all models is silent on the issues that arise when there is one sender and multiple receivers. For a better analysis of mass communication, use a model like the Laswell model of communication. We have the criticisms of Shannon-Weaver's model. First, it can be applied more for interpersonal communication than group communication and mass communication. Receiver plays the passive part in the communication process as sender plays the primary role that sends messages. Feedback is taken as less important in comparison to the messages sent by the sender. The model is taken by some critics as misleading misrepresentation of the nature of human communication, as human communication is not mathematical in nature. That is the Shannon-Weaver's model of communication. Thank you for watching. I will end this by leaving you a simple quotation by Charles Dickens. Electric communication will never be a substitute for the face of someone who with their soul encourages another person to brave and true. Don't forget to like, share, and subscribe. And click also the notification bell so that you will be notified for the next video.